Welcome, students. This is Mr. NK, setting us up for a nice new lesson. As we begin these weeks after spring break, we were going to start on some new lessons, continue on in our learning of pre-calculus, because you are going to need to know this for calc. You are going to need to know this whenever you go to college. It's important for you to learn this stuff now. And it's a good opportunity for you guys to learn for the sake of learning. So let's get to it. We are going to start in 10.7.1, so you have that packet, and you've got 10.7.1 right there. It's called partial fractions, and specifically what we're going to be focused on is decomposing fractions. We'll talk about what that means in a few minutes, but just as a quick reminder, we've been going through matrices before, and what we finished up last before the break was using Cramer's rule and determinants. Now, determinants were a really fun equation in order to get down a single matrix to a single individual number. And the determinant you found by doing a little multiplication, breaking things down. It's always good to do determinant with a row that has zeros in it, because that eliminates a lot of bad choices. And if we do the determinant for a system of equations, but we replace one column, if you look over here, if you replace one column, the x column, the y column, or the z column, with the function, or with the matrix B, the resulting matrix over here, if you replace column A with matrix B, you end up, and you find the determinant of that, you'll end up getting a specific number. And that number helps you to get the value of x. Specifically, you take this number and you divide it by the determinant of the original matrix A, you'll get the value of x. And it turns out that x is 12/23. You do that to column B. You replace column B with the matrix B, or you replace the column for the y values with the matrix B, and then the column for the z values. Each time you do that, you'll end up with very specific values, and those turn out to be our x, our y, and our z solutions. So that's what we did before the break started, as a quick reminder. Now we're going to go into something that does require matrices, or we do use matrices, but it's going to be a little bit later. So, to start off, let's go ahead and add some fractions. Hopefully you know how to add fractions pretty efficiently. As a quick reminder, if we want to add fractions, we need to get a common denominator. It's kind of like this. You have two pieces of pizza. Let's say this pizza is a big pizza. It's cut into 7 slices. 1, 2, 3, 4, 5, 6, 7. All those slices are a certain size. Then you got another pizza that's cut into 4 slices. Now it would be weird to add these because the pizza with 7 slices, each slice is smaller than the pizza with 4 slices. So in order to add them, we actually need to cut the pizzas to make them the same size. And the way that we do that, the process by which we do that, is just getting the lowest common denominator. And we don't actually need the lowest one, but the lowest is usually the easiest one to get. I mean, we could cut these into, pieces that are hundreds of tiny little fractions of the pizza. We don't need that, but that's why we choose the smallest one. So in order to do this, we're going to multiply this side by 4/4 and this side by 7/7. That'll give us a common denominator. Now again, the reason why we multiply by 4/4 is it doesn't change the value. 4/4 is really the number 1. So whenever we say multiply by 4/4, we're really saying multiply 5/7 by the number 1. It doesn't change 5/7, it just makes it look different. Okay? So whenever we go ahead and multiply that, if you remember, when we multiply fractions, we multiply the top and the bottom. So 4 times 5 is 20. On the bottom, 4 times 7 is 28. Plus 21/28. And then whenever we add them, we do not add the denominators. Because again, the denominators are how the pizza is cut, if you think about it in terms of pizza. we now have a pizza that's cut into 28 slices. And what that means over here to the pizzas that I actually drew, let me just use purple. It means that I took each of these 4 slices in the pizza that's cut into 4, and I cut them into 7 slices. That's 1, 2, 3, 4, 5, 6, 7. I think that's 7 slices. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 slices, and I took each of the 7 slices in the pizza that's cut into 7 slices, and I cut them into 4 slices. Okay, so that's how we got 28 out of 28. And then the numerators, we just add them. 20 plus 21 is equal to 41. Now you can look at that and be like, okay, can we simplify that? 28 is divisible by 7 and 4. 41. Is 41 divisible by 4? No. Is 41 divisible by 7? No. So they can't be simplified. 41 is also not even, so it's not divisible by 2. All right. So by adding these fractions, you get a common denominator and you add them. Now, as simple as that is, this one looks a little bit more complicated, but it's really the same process. The only difficulty is that we have different or more complex denominators. Just like before, we're going to get a common denominator by multiplying each one by the denominator for the other one. But got to do it to top and bottom because that is really the number 1. X minus 2, x minus 2. Okay, whenever we go ahead and multiply those, a big thing that you want to watch out for is distributing. Okay, we're not going to do the bottom just yet. We'll do the top, though. That x needs to multiply by the 1 and the 3. And don't forget this negative. We're going to put that negative into both of them. That 2 needs to multiply by the x and by the negative 2. So if we look at the numerator, we end up with negative x minus 3, okay, over x plus 3 times x minus 2, plus 2x minus 4 over x plus 3 times x minus 2. Common denominator, and the numerators we need to combine. Now, we're going to put these all as one fraction before we combine them. Again, there's some steps that you can skip. This step is kind of a midway step. It's one that oftentimes you can skip because you're pretty efficient at adding fractions by now. But I just want to make sure everybody can see it. Everybody knows what to do. X plus 3, x minus 2. Okay, we got it all under one common denominator. Now, combining the like terms on top, we're going to do that, and we are also going to distribute the bottom. So that becomes 2x minus x is just x. Negative 3 minus 4 is 7. On bottom, we get x squared. Minus 2x plus 3x minus 6. Okay, and the bottom has some like terms in it. We can simplify those, and we end up with x squared plus x minus 6. And that is our final answer. Yay! Okay, so combining like, or adding fractions, we want to get a common denominator and combine them. Now, that is something you learned quite a bit back in the past, and we worked on it in Math 3 whenever we were dealing with rational functions. But what if we want to go backwards? What if we start with this answer and we want to go back to break it down into this answer? Into the negative 1 over x minus 2 plus 2 over x plus 3. There's a way to do that. It takes a little bit of work to get used to, but there is a way to do it. Okay? So, first of all, whenever we have a function, we want to think about the form that it'll break it down into. And in order to do that, or whenever we have an expression and we want to break it down into separate fractions, the main thing that we want to look at first is that denominator. How can we break up that denominator? Now, looking at this denominator, we can't really break it up pretty easily. And let me just build on that. We want to break up the denominator. If I think about this number, this fraction, 8 over 21, okay? If I want to break this down, I don't look at the numerator so much. The numerator can change. We just add those. We can split it apart in a lot of different ways. The denominator can actually be broken down into 7 times 3. And that's actually the most useful because it allows us to break this fraction into something over 7 and something else over 3. We don't know what goes on the top, but we do know that whatever goes on the top, it has to add up to 8. The same thing is true whenever we're dealing with rational functions. That denominator, we are going to break up into, we're going to break it up into 2 different denominators, or 2 different parts. And the way to do that is first to just use our nice x method to break it down. 2 numbers that multiply together to get -4, add together to get 3. And 4 and -1, not -3, -1, work out perfectly fine. So this expression can be rewritten as x times over x plus 4 times x minus 1. Okay? But because those are the 2 separate fractions, or separate factors, we can actually break that into x plus 4 on one plus x minus 1 on the other. We don't know what goes on the top. Okay? This top part is a mystery, and that's what we're going to be spending our time working on partial fraction decompositions finding out. Because it's a mystery, we do have names for them. We're going to call this capital A and capital B. Okay? We could call it anything we want. I'm going to go with capital A and capital B because, as you'll see a little bit later, we have a bit to do with fraction, or with matrices here. All right, with that said, I'm going to bring this video to a close. Avengers NK.